In this video, we'll come up with another way to graph quantitative data. It's called a box plot, and sometimes it's called a box and whisker plot. We'll also have a definitive way to decide whether a data value is an outlier. Box plots are constructed using the 5-number summary of the data. As such, they display the center of the data, the median, the spread of the data, the interquartile range, the maximum and the minimum, and as we will shortly see, they even display outliers. There's nothing like a good example to see how the process of constructing a box plot works. So we look at a small data set consisting of the annual incomes for a sample of 12 households. The units for the data are thousands of dollars. Notice that the data is not sorted from smallest to largest, so this will be our first step. The first step in constructing a box plot is to find the 5-number summary for the data. To this end, we sort the data. We find the median by averaging the 6th and 7th observation. And then we go on to find both quartiles, Q1 and Q3. So the 5-number summary is 27, followed by 37, followed by 47, 61, and 104. Now the question arises, is 104 an outlier? It is certainly separated a lot from the next lowest annual income. On the next slide, we'll learn how to test for outliers. The test will involve the interquartile range, or the difference between Q3 and Q1. So we calculated it here. The interquartile range is 24, or $24,000. There is an agreement among statisticians that any data values that are more than 1.5 interquartile ranges away from either Q1 or Q3 should be considered outliers. So the first thing we need to do to test for outliers is to multiply the interquartile range, which was 24, by 1.5 or 1.5. That turns out to be $36,000 or $36,000. So to be an outlier on the low side, the household would have to be below Q1. In fact, it would have to be 36 units below Q1. So we do the computation Q1 minus 1.5 interquartile ranges. 37 minus 36 is 1, or $1,000. So a household would have to make less than $1,000 annually to be a low outlier. To be an outlier on the high side, the annual income would have to be larger than Q3. How much larger than Q3? Add 36 to Q3. So you've got 61 plus 36, 97 or $97,000. To be a high outlier, the household income would have to exceed $97,000. These numbers 1 and 97 are called fences. They are not part of the data, and they'll not be part of our box plot. We compute them only so that we can identify outliers. Our data set does have one outlier, the value 104. 104 exceeds the upper fence, and hence it is a high outlier. So the lower fence and the upper fence tell us what data values are not unusual. Any data values that are between the two fences are considered ordinary data values. But data values outside the fences are considered unusual or considered either high outliers or low outliers. we will build our box plot using the data within the fences, and then we will identify outliers separately. So here is a 5-number summary of sorts. It has the minimum value, Q1, the median, Q3, and this 72 is the maximal data value within the fences. So the next step is to construct the box plot. We're going to draw and label a horizontal axis that spans the data. The smallest data value was 29, so we have to go below 29, and the largest was 104, so we have to go above 104. Next, we're going to sketch vertical lines for the quartiles, Q1 and Q3, and for the median. These 3 lines are called the hinges of the box. Now we're going to connect the hinges with 2 parallel lines. Now we have the box of our box plot. The box contains the middle 50% of the data. You can read the values of the medians and quartiles off of the box, and hence you could compute the interquartile range if you wanted to. Next, our box is going to grow whiskers. From the lower end of the box, we're going to draw a horizontal line segment connecting the box to the minimum value within the fences, which in this case is 29. Then draw a similar line connecting the upper end of the box to the maximal value within the fences, which in this case is 72. These are what I refer to as the whiskers of the box. Finally, plot any outliers as single points. In this case, we have one outlier of 104. This is the box plot that StatCrunch produced. I added the labels. Can you see how the box plot really tells us a lot? It displays the center of the data. It gives us an idea of the spread of the data. The width of the box, or the IQR, is what measures the spread. It also gives us the range of the data, both with the outlier and without the outlier. And it identifies outliers. The final slide displays the histogram and box plot for a side-by-side comparison. Both graphs allow us to identify the center and the spread of the data. Both actually show us that the data is skewed to the right because there is a high outlier. The histogram gives us a little bit more detail about a secondary peak in the $53,000 to $60,000 range.